Welcome to this predicted paper, guys. It is a foundation paper. It is just a best guess of what might come on paper 2 based on what's already been tested on paper 1, so we're ignoring that, and based on these are generally non-calculator questions. Your best revision strategy is to make sure you're comfortable with as much content as possible, but have a go at this and good luck. Question 1, we've got a tally chart with a missing frequency and a missing tally, and the first question is just to fill those in. So let's have a look here. We've got 5, 6, that missing frequency is 6. And then down here, we've got a frequency of 13, but no tally. So I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. There's the first 2 marks. Next question, we're going to put this tally chart and frequency table onto the graph. Just check your scale first. It's not going up in ones, 1, 2, 3, 4, 5. It's going up in twos, 2, 4, 6, 8, 10. I'll just fill the rest in. That'll be 12. Now we can draw the rest of the bar chart. Beech trees is up to 15, so I'm going to go right up to 12, 14, and then halfway up there, because I don't want to go all the way up to 16, I want 15. Oak trees is 18, so again I'm going right up, 16, 18. Rowan trees is 6, so that's a bit nicer, that one. And then finally other would be 13, so right up to 10, 12, 13, midway between that bar. The second part of this question says there are 60 trees altogether. What percentage are oak? So we're just going to answer that on this page, save me scrolling down. If we look at oak, there are 18, and I'm just going to write that as a fraction first. That would be 18 out of 60, and you would generally get a mark for writing the fractional version of what you're being asked. We now need to change this into a percentage, so what I'm looking for is out of 100, and this is a non-calculator question. First thing we can do is try and get this to out of 10. That will be dividing by 6. 60 divided by 6 is 10. And I can do the same on the top. If I just divide that by 6, 18 divided by 6 is 3. Why do I want my fraction out of 10? Well, that now makes it easy to get it out of 100. 10 times 10 is 100. I'm going to do the same on top. 3 times 10 is 30. The minute you've got a fraction out of 100, the top thing is your percentage. So there's the answer to part 2 of this question. Question 2, we've got quite a bit of fraction work to do. First thing is adding a fraction. Never ever work in mixed numbers when you haven't got a calculator. So let's change this into an improper fraction. I'm going to do 6 times 2, which is 12. Then add the 1. That gives me 13. And because I started in halves, I'm still working in halves. Then we're going to add on 3/4. When you're adding fractions, you need common denominators. You can get common denominators by timesing these together, or sometimes you can just change one fraction. If I double this fraction, I will get 26 quarters. I've not doubled the fraction, I've doubled the top, doubled the bottom. I've made an equivalent fraction. Now I'm just going to add on 3/4, and 26 quarters add 3/4 is 29 quarters. I'm quite happy to leave it in that form. It doesn't say simplify, so that would get full marks. It is only a 1 mark question. If you do want this as a mixed number, well, we're just going to count up in 4s, and 4 7s are 28, so that would be 7 1/4. Part 2, how do we find 4/7 of 63? We're going to divide by the bottom and times by the top. So we're going to do 63 divided by 7. How many 7s into 63? The answer is 9. 7 9s are 63. So we've dealt with that bit. Now we're going to take our answer and times by the top, times by 4. 4 9s are 36. Showing that a fraction is bigger than another fraction, again, we're going to need common denominators here. To compare fractions, like adding fractions, you want common denominators, and I am going to need to times these together. So 5 9s are 45. Change both fractions into 45ths. What do I do to this 5? I times by 9, so I'm going to times this by 9, and you get 36 45ths. What did I do to the 9? I times by 5, so I'm going to times this by 5, and 7 5s are 35. We've got 36 45ths, 35 45ths. That should be enough to say that this is bigger than that, just showing a common denominator and showing that the 36 is bigger than the 35. Similar question for part C. We're looking for a fraction that's bigger than this, but smaller than this. It's again comparing fractions. So if we look for common denominators, I'm going to change these both to 20ths. What do I do to the 5? I times by 4, so I'm going to times the top by 4. What do I do to the 4? I times by 5, so I'm going to times the top by 5. And what we've got is 4/20ths and 5/20ths. And if we're looking for something bigger than this but smaller than this, I want something in between those fractions. So all we've got to do is say what's between 4 and 5, and the answer is 4.5. That is correct. That fraction is between these two, but we're not allowed that as a fraction. You can't have a decimal in your fraction. So all I'm going to do to get rid of this decimal is double it. 4.5 doubled is 9, and then double the bottom. We've got 9/40. That is your final answer. Question 3, we've got some more fraction work to do and a bit of decimal work to do. So let's have a look at this first one. This is just working out an equivalent fraction. How has 1/3 changed to 2 somethings? Well, we've just doubled the top. So I need to double the bottom. And 3 doubled is 6. 1 and 1/7, that's just our mixed number improper fraction work again. So I'm going to change this to an improper fraction. 1 times 7 is 7. Add on the 1 is 8. Part B, we've got to do 0.8 divided by 2. I'm not going to start with that. I'm going to do 8 divided by 2. And 8 divided by 2 is 4. Well, if 8 divided by 2 is 4, 0.8 divided by 2 must be 0.4. Sometimes it's nice to think of this as money. If you've got £8 divided by 2, you've got £4. If you've got 80p divided by 2, you've got 40p. Part 2, similar question but multiplying here. So we're going to try and do 1.7 times 2. I'm not going to do that. I'm going to do 17 times 2. Just work without decimals. 2 7s are 14. 2 1s are 2. Add this on gets me 3. So 17 times 2 is 34. If we wanted to do 1.7 times 2, if we look at this question, we've just got one number after the decimal point. So I'm going to write 34 and then just put a decimal point somewhere. So there's one number after it. There's your answer, 3.4. Question 4, we're moving on to some BIDMAS work. So let's have a look at this. 4 add 16 divided by 2. Don't rush with these. Division becomes before addition. If we just write BIDMAS down to remind us, working left to right, division before addition. So we need to do 16 divided by 2 first. And you get 4 plus 16 divided by 2 is 8. And then we can just work that out. 4 add 8 is 12. And in the next part of this question, we're just going to put some brackets in place to make this calculation correct. Just going to rewrite this calculation out. We've got 5 times 7, add 1, divided by 9. And that's meant to equal 4. When you're putting brackets into this, remember the brackets are the thing you're going to do first. So what I'm going to try, well, we know that multiplication would come first anyway, so we'll leave that alone. 1 divided by 9 is horrible. You're going to get a horrid decimal there. So what I'm going to do is just try putting brackets around this bit and see what happens. Just make sure we cover all this off first. 5 times 7 is 35. Then we're going to add 1. So if we do all that bracket first, we get 36. Then we're going to divide by 9. And 36 divided by 9 is the 4 that we're looking for. Question 5, just some powers work to do and square rooting. So 5 squared is 5 times 5, not 5 times 2. And 5 5s are 25. The cube root of 64, your cube roots come from timesing things by themselves 3 times. So if you don't know these, you can just start to build upwards. 2 times 2, 2 2s are 4, times 2 again is 8. We can do 3 times 3, that's 9. Times 3 again is 27. 4 times 4 is 16. Times 4 again is 64. There's your answer. That comes out at 64. So the cube root of 64 is 4. Part B to this, we've got to do 2 cubed. Well, we know 2 cubed, 2, 4, 8. The square root of 49. Well, I know the square root of 49 is 7 because 7 7s are 49. And we're going to multiply those together. 7 8s are 56. Question 6, we're just going to change these fractions to a decimal. A lot of people just know that 9/10 is 9 divided by 10. Which is 0.9. Again, a lot of people know that 3/4 is 0.75. If you don't know how to do that, I'll just show you a method that can help you if you get stuck. 3/4 is how many 4s go into 3, and the answer is 0. So we need some decimals and some digits to work with. 4s into 3 is actually no remainder 3. Then we're going to say 4s into 30. Well, 4s into 30 would be 7. 4 7s are 28. Remainder 2. I got to 28 and I was aiming for 30. 4s into 20 is 5. So that's where the 0.75 comes from. If you don't know that, you're going to need to do your bus stop division. And part B of this question, we've got a plank of wood which is 2.4 meters long, cut into 6 pieces. So what we need to do is share this 2.4 into 6. It's effectively a division question. 2.4 divided by 6. I'm not going to do that. I'm going to do 24 divided by 6. Well, 24 divided by 6 is 4. 6, 12, 18, 24. So I know the answer to this. And if I know the answer to that, I can work out the answer to this. 24 divided by 6 is 4. 2.4 divided by 6 must be 0.4. Question 7, we've got some plans and elevations work, and we've got the front and side elevation of a prism drawn below with a pentagon, so a 5-sided shape as its cross-section. So this is the cross-section, which we'll come back to in a second. What we need to do is draw the plan. So that's what this shape looks like from the top. So you've got to imagine you were kind of staring down on this shape from the top. This is what you see when you look at it from the side. And this here is what you see when you look from the front. So if I'm looking from the top, imagine flying over this shape, I'm definitely going to see a shape that is the same width. So 1, 2, 3, 4, 5, 6 across. I've literally drawn this line there. What I'm going to see is something that's this like long, or this deep, if you like. So as I'm flying over the top of the shape, I'm going to see something that's 1, 2, 3, 4 down. I'm effectively going to see a rectangle. There's something else I will see. If we think about I'm over the top of this, there's something that happens when you're 1 across. You'll see this kind of top of the shape, if you like, the flat bit on the top of the shape, and then this bit here is like the slopey bit. Quite a difficult one to try and explain just doing this on a phone, but just got to imagine you're looking down on this shape from the top. So you're going to see something that's 6 across, and if you're on the top on this side, you won't really see a slopey bit and a flat bit, but you will see something that is 4 deep or 4 towards you. Part B says work out the volume of the prism, and there's a reason they told us that this was the cross section. What we need to do is work out the area of this. For volume, I need the area of the cross section. So I've got 1, 2, 3, 4, 5, 6, and then I've got some part squares which should make full squares. Well, I missed that one, 7. If we look at these two here, that makes a full square, so that's 8. And then these two will also make a full square, so there is 9 full squares on this cross section here. That is the area of the cross section. If I want volume, I need to multiply by how long this shape is, and the length of the shape is this length here. 1, 2, 3, 4, 5, 6, 9 sixes, or 54. And if this is a centimetre square grid, that will be centimetres cubed because it's a volume. Question 8, we've got some probability work to do. We've got 20 crayons in a box, and these are the different colours. And the first question says, which arrow is the probability of blue? Well, there are 8 blue, and that's 8 out of 20. And 8 out of 20 is the same as 4 out of 10. Just start to simplify that probability. And 4 out of 10 is very close to halfway. Halfway would be 5 out of 10. So I'm thinking 4 out of 10 must be arrow C. It's just under halfway, so that's the one I'm going to go for. Part 2 says what's the probability of yellow? Well, if we look up here, there are no yellow crayons, so that's impossible. That has to be arrow A. And then part 3 says what's the probability of not black? Well, black is going to be 5 out of 20. And 5 out of 20 simplifies to 1/4. So if we just divide top and bottom by 5, we get 1/4. And I think if we look at this number line, that looks like a quarter. So if a quarter is the probability of black, then not black has to be everything else, which is 3/4. Little sneaky one here, because they're expecting you to go for a quarter, when actually we want to go for 3/4, not black. Part B says Darren puts 16 more crayons that are either blue or red into the box. He puts these with the 20 crayons that are already there. So straight away we know we're out of 36. There was 20, he's put 16 more in, we're now out of 36. He says that the probability that he picks a blue crayon is evens. So what I need is half of 36 on top, and that is my probability of blue. Half of 36 is 18. So we know that the probability is now evens because 18 is a half of 36. This here is the same as a half. That must mean there are 18 blue crayons. If we keep looking at blue crayons, blue went from 8 to 18. And that means there are 10 more blue crayons that he put in. What that means, if he put 16 crayons in total, then for red, well, he put 10 more blue in. There must be 6 more red. Question 9, we're looking at a distance time graph. Okay, so we've just got a girl, Sarah, she's walking from home to a shopping centre. We're just mapping out the journey. First thing it says is state an assumption that has been made when the graph was drawn. And what we've got is nice straight lines. There's no curves going on here. There's no like gradual change. And what that implies is that she was walking at constant speed all the time. Part B says, what is the distance from Sarah's home to the shopping centre? Well, if we start at home on 0 and we go right up here and hit the shopping centre, then we just need to read this measurement there. So we've just got to figure out what the scale's going up in. I think it looks like 2s. Let's just check. 30, 2, 4, 6, 8, 10. Yeah, so this will be 36 kilometres. Part C, the real part C, says between which 2 times did Sarah stop, and explain how the graph shows this. Well, if we look at this distance scale, right here, she stays at the same distance from home. She's not going anywhere. So that means she stopped. And all we need to figure out is these 2 times. Well, it's definitely till 11 o'clock. And then we just need this time here, which looks like it's bang in the middle of 10 and 11. So that must be 10:30. How is that shown on the graph? It's a horizontal line. You would get away with saying that's a flat line as well. Question 10, we're making some cupcakes, and these are the ingredients to make 20 cupcakes. The first part of this question says, how many eggs do we need to make 60 cupcakes? So this is just a scaling problem. If we know that 20 cakes is 4 eggs, and we want 60 cupcakes, then we just got to figure out what we're doing to get from 20 to 60. That is timesing by 3. So we're going to do the same on this side, multiply by 3, 4, 8, 12 eggs. Part B says how much butter is needed to make 5 cupcakes. Well, we'll do the same thing again. We'll go back to his recipe. 20 cupcakes is 140 grams, so let's write that. And we're trying to find 5 cupcakes. And again, we're just going to figure out what we've done. It's always multiply or divide. We've divided by 4 there. 20 divided by 4 is 5. So we're going to do the same thing there. Divide by 4. In order to divide by 4, you can half and then half again. So a half of 140 is 70. And a half of 70 is 35. Part C says we've got 210 grams of cocoa powder and everything else. We're not bothered about everything else. We've got as much ingredients as we need. And what we want to know is, can we make 75 cupcakes? Well, we need to know how much cocoa powder we need for the 20 cupcakes. So I'm going to set that out now. We need 60 grams, and that does 20 cakes. What I'm going to do is count up in 60s and also count up in 20s until we get to 210. So let's do that. We can say another 60 will be another 20. That's 40 altogether. Another 60, another 20, another 60, another 20. I'm just going to check in how much cocoa powder I've used. 60, 120, 180. That's 240. No good, I've gone too far. 60, 120, 180. How much have I got left to get from 180 to the 210? I've got 30 grams left. So I've got another spare 30 grams. And if 60 grams is 20 cakes, then 30 grams must do 10 cakes. I'm just going to double check this again. 60, 120, 180. That's 210 grams. I just need to check how much cupcakes I've made. 20, 40, 60. That's 70 cakes. Just double check and answer the question. Rashid says he can make at least 75. Is he correct? No. And you can just point to that maths and say, it can only make 70. Question 11, we've got a triangle ABC. It's a typical constructions question, and the first part says construct the bisector of angle BAC. So from B to A to C. This is going to be extremely dodgy doing it on the device I'm doing it on, but we'll have a go. You'll have to use a compass for this, and what you'll do is you'll put your compass point there on the angle, and you'll draw just part of a circle around it, an arc. You're then going to put your compass point here and draw another part of a circle around that, another arc up there, and then without changing your compass, it goes there, and we draw another arc around that. And what you do, if you join your angle to that cross, you've bisected that angle. You've cut that angle in half just with a compass. Part B says construct the perpendicular bisector of AC, which is that straight line there. And again, we're going to use a compass. You'll put your compass point back here, open it beyond halfway point of this line, and draw a much bigger arc around this point. Again, without changing your compass, move over to this side and draw the same arc or a mirror image of that arc. And what you get is these crossover points. We're going to connect them with a ruler. And what you've done is cut that bottom red line clean in half just with a compass. The final bit, we've got to shade a region inside the triangle that's nearer to AC than to AB. Well, AC is the bottom line. AB is this side line. Where is closer to AC, the bottom line, than the side line? It's anywhere underneath that first blue line that I drew. That is closer to AC than AB, so we've done that. And then it says nearer to A than to C. Well, this is A, this is C. I want to be on the left-hand side of my red line, so I need all of this. And the only bit I actually want is the bit that satisfies both things, so I shouldn't have actually shaded this in, because I want under the blue line and to the left of the red line. Question 12, we've got some brackets to expand. I'm just going to rewrite them. So we've got 4c, lots of d minus 5, brackets, just multiplication. So I'm going to multiply that together and then multiply that together. And 4c times d is 4cd. And then 4c times minus 5, well, 4 5s are 20. 4 times minus 5 will be minus 20. And don't forget it was 4c times minus 5, so we get minus 20c. Similar thing here, but make sure we multiply everything by everything. So I'm going to times those together, those together, those together, and those. Some people use a grid for that. 3x times x is 3x squared. 3x times minus 4 is minus 12x. Then we're going to do plus 2 times x, which is just plus 2x. And plus 2 times minus 4 is minus 8. That's the expand part. We now just need to simplify. You've got minus 12x and you're adding 2. If you start at negative 12 and add 2, you end up with negative 10. So altogether we've got 3x squared, negative or minus 10x, minus 8. There's the simplify part. Question 13, we've got a jacket that has been reduced by 20% and it's been reduced to £56. Got to be super careful with this one. This is a reverse percentage question. What's happened is we've come down by 20% from 100%. And that's what we don't know. We don't know the starting price of the jacket. If we've come down by 20%, we've got 80% left. And 80% is the £56 that we're told about in the question. So now we know 80%, we can scale down to something in order to scale back up to the 100%. What I'm going to do first is come right down to 10%, and 80% divided by 8 will give me 10%. So what I need to do is take this 56 and divide it by 8. 56 divided by 8 is 7. In order to go from 10% to 100%, I'm just going to times by 10. So I'm going to do the same on this side. Multiply by 10. £7 multiplied by 10. My original jacket cost was £70. Be super careful. The temptation here is to find 20% of that and add it back on. And I know that's what a lot of people are going to want to do. 20% of 56 is not the same as 20% of 70. Promise you. So you can't find 20% of 56 and add it back on, because that's not the same 20% that we took away originally. You must use this reverse percentage idea down at the bottom. And then question 14 says, by rounding to one significant figure, what is the cost of 3.9 kilograms of apples at 87 pence per apple? Well, one significant figure would be 4 kilograms, and 87 pence per kilogram, sorry, not per apple, would be 90p. We're going to do 4 times 90. 4 nines are 36. So that would be 360 pence. And be very careful, you've just got to make sure you've got decent units here. I would go for £3.60. There's your final answer. Question 15, we've got quite a meaty area question to do. We've got a floor plan of a room. My mate Tim's buying some carpet tiles, and each tile is a square that measures 50 by 50. I'm going to stop straight away because this is centimetres in the question, and then up here we've got metres. So I'm going to change this to centimetres, just times in by 100. And same thing with the 4.5. If I times that by 100, I get 450 centimetres. That would get a mark just for doing a unit conversion. What I'm going to do to start with is just see how many of these tiles will fit in this room. And I'm going to do that just by counting. If each tile is 50 by 50, then I can just count across. I can say, well, that's 50, 100, 150, 200, 250, 300, 350, 400, 450. Just counting across, I'll get 1, 2, 3, 4, 5, 6, 7, 8, 9 tiles across. I'm going to do the same for up and down, the up and down measurement. I'm going to say, well, we've got 50, 100, 50, 200, 50, 300. That's 1, 2, 3, 4, 5, 6 tiles up. And what I can work out is the total tiles. If it's 9 across and 6 up, I'm going to do 9 multiplied by 6, which is 54 tiles. That's how many you need to cover the entire floor. This next part of the question says tiles are only sold in packs of 10. That's okay. I'm going to have to go up to the next 10, which is 60 tiles or 6 packs. And then it says each pack costs £20. So I need 6 packs, and I'm going to multiply by £20, £20 for each pack. Well, 6 twos are 12, and then I'm just going to bolt a 0 on the end because I actually wanted to do 26s, not 2 6s. This here is the cost of your tiles. And we're slowly working through this. We'll just look at the next bit. It says Tim pays a fitting at a rate of £7.50 per square metre with any fraction of a square metre rounded up. So now it's talking about square metres. I need these measurements again. I need to find the area of the floor in square metres. So let's have a look at that. We're going to say, well, it's 3 up multiplied by 4.5 across. This looks horrid, but it's not too bad. 3 times 4 is 12. 3 times 0.5 is just a half of 3. Okay, 0.5 times 3 is just a half of 3, and that's 1.5. So my area is 12 plus 1.5, which is 13.5. It does say any fraction of a square metre is rounded up, so this is now 14 square metres. Now what we need to do next is say, well, if there's 14 square metres, I need to do 14 lots of £7.50. So that's my square metres. It's costing me £7.50 for each square metre. Again, this is not as bad as it looks. It's not great, but it's not super bad. I'm going to do 7 times 10, which is 70. I'm going to do 7 times 4, which is 28. And then I'm going to do 0.5 times 14, which is 7. I'll just go through that again. I'm going to do 7 times 10, 7 times 4, and 0.5 times 14, just breaking this apart. If you did a column method, you'd get a similar set of results. So 70 add 28 add 7 is 105. That is what we cost for fitting. Don't forget we need to add on the 120 for the tiles. 105 add 120 is £225. Something a bit nicer next door. Question 16, we're just going to do 4 take away 5. We'll start at 4 and take away 5. You will end up on -1. And then this bottom question that's just sneaking off the page, sorry about that. We're going to do 2 times -3. Well, 2 3s are 6. 2 times -3 is -6. Question 17, we've got a sequence and we just want to do the next term. All we need to do is figure out what's happening between terms. We're adding 4 there. We're adding 4 there. And we're just adding 4 every time. So I'm going to do 18 add 4, which is 22. It then says write an expression for the nth term. Well, if we've figured out we're adding 4 straight away, write down 4n. It's going up in 4s. It's linked to the 4 times table, which mathematically we write as 4n. Then we need to just figure out how we change the 4 times table into this. Well, the 4 times table is 4, 8, 12. And we've got 6, 10, 14. I think I'm adding 2 to the 4 times table to create this sequence here. Some teachers will teach you about the 0th term. If you just figure out what that number is, well, I'm going to take 4. If I'm going the other way, you'll get the same answer, +2. So your final nth term expression is 4n plus 2. Part C says, explain why 511 is not a term in this sequence. There's lots of ways to do this, but because this is only 1 mark, you can get away with just saying 511 is odd, and this sequence is all even. And it always will be because we're adding 4 every time, which is an even number. The mathematical way, if it was more marks, would be to say, well, does 4n plus 2 ever equal 511? And then solve this equation, take 2 from both sides, you get 4n equals 509. Divide both sides by 4, you'd get a decimal. And because you've got a decimal solution to what n would be, that's showing that it's not a term. But for 1 mark, that's enough. Question 18, a bit of algebra to do, so we're just going to simplify. We're starting with 3t and we're taking away 2t. We've got a single t. We're then going to do 5u's, and it's positive 5u's, add 3 more u's, altogether we've got 8u's. Part 2, 6a times 2a squared. Well, 6 times 2 is 12, and a times a squared is a cubed. And then part B, and again, sorry that this is going off the bottom of the page, we've got y equals x squared minus 1, and we're trying to make x the subject, so we want x to be on its own. First thing to do is get rid of that minus 1 by adding 1, and you need to do it to both sides. And we get y plus 1, just working downwards, equals x squared. Minus 1 add 1 goes away, that's why we did that step. Final step, we want x on its own, and the opposite of squaring is square rooting. And what we get is the square root of y plus 1 equals x. Question 19, we've got a diagram that's been drawn using parallel lines. So we've got some parallel line angle facts coming up. We're saying x is 55. But what I see when I'm looking at x is this, this, and this. X is down there. 55 is up here. That is classic alternate angles which are equal. We're also told that y equals 70. Again, when I'm looking at y, I see this shape. And we've got your parallel lines, and 70 is there, y is there. And again, they are classic corresponding angles which are equal. Question 20, we've got a quadratic that we're going to solve by factorising. You've got an expression like this and you're factorising it. We want double brackets. We know there's going to be an x in each bracket because x times x gives me the x squared. What I need for the numbers in these brackets is something that adds to make 4 but multiplies to make minus 12. So I'll start with the numbers that multiply to make minus 12. I think we've got -6 and 2. I've also got 6 and -2. And I'm going to stop there because these two here, 6 and -2, they add together to make +4. So I don't want these two. Just double check. 6 times -2 is -12. And 6 add -2 is +4. So they're my two numbers that are going into these brackets. We've got a +6 and a -2. Question 21, Venn diagram question to solve. We've got 50 people. We know it's about cars or bicycles, and some of it's been filled in. So one person doesn't have a car or a bicycle. 10 people have both. And then we've got a ratio problem. It says car to bicycle is 2 to 1. So let's just pull that out. Car to bicycle is 2 to 1. Altogether, there are 3 parts in that ratio. We just need to figure out how many people we're sharing into it. Well, we know that there's 50 people altogether. So I'm going to start with 50. I'm going to take away the 10 and the 1. So I'm going to take away 11. And that tells me how many people going into the other parts of the Venn diagram. 50 take away 11 is 39. Back up to this ratio, I'm going to take my 39 people and divide it by 3. Let's just use a bus stop just to make sure we've got that right. 3 is into 39. 3 is into 3 is 1, and 3 is into 9 is 3. So each part of this ratio is worth 13. So this here is 26, 2 13s, and this here is just 13. So what I can do now is put those numbers into my Venn diagram. We've got 26 people have a car. We've got 13 people have a bike. Let's just double check that these add to 50. 26, 36, 39, 49, 50. Yeah, we've got the right numbers. We're then asked to find the probability that someone has a bicycle. Well, here are all the bicycle people. And it's not only has a bicycle, it's has a bicycle, even if they have a car as well. So what I need is 10 add 13, which is 23. And it's out of everyone, the 50 people. And question 22, just a bit of exact trig. It asks about sine 30. If you're ever unsure about your trigonometry on a non-calculator paper, usually go for a half, because that's often the case. Not always, but it's better than doing nothing, or better than not attempting the rest of the question. Sine 30 is a half. Now question 23, we've got some algebraic work to do once again. We've got these little rectangles, and my mate Jess has put 3 of them together, and we want an expression for the perimeter. So what I'm going to do first is fill all these measurements in on this combined shape. Just showing all the side lengths there. And then I need to make sure I've got the perimeter, which is all those added together. So I'm just going to count up A's. 1, 2, 3, 4, 5, 6. We've got 6 A's. And then counting B's. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We've got 10 B's. This simplest form bit just means if you put A plus A plus A plus A plus A plus A, you're not simplifying it. You will get marks for that, but I just counted them up and then put the answer at the end. Someone's gone on to work out an area expression for us, and we're asked to factorise it. So we've got 6AB add 6B squared, and we're just looking for common factors. Well, 6 clearly goes into both things, so I'm going to put a 6 as a factor. A only goes into the first term, but not the second, so I can't take A out. B goes into this, and B goes into this. So B is a common factor as well. Now we just need to figure out what goes inside the bracket. 6B times something gets me 6AB. 6B times A gets me 6AB. And then 6B times something gets me 6B squared. Well, 6B times B, and it would be a positive B, gets me 6B squared. There's your final factorised expression. Question 24, some shape work to do, and we're trying to show that angle A is 132. If you've ever got some shapes like this, some regular polygons, there's 2 calculations that more or less guarantee you some marks. So that is a 1, 2, 3, 4, 5, 6-sided shape. If you do 360, and it's always 360, divided by 6, the number of sides, you're likely to get some marks. So 360 divided by 6 is how many 6s in 360? 6 into 3 is 0 remainder 3. 6 into 36 is 6, and 6 into 0 is 0. That there generally starts to pick up marks. We definitely get marks if we move on and say, I'll do 180. Take away that answer, and we get 120. What have you just worked out when you've done that? Well, this 60 is called the exterior angle of this shape, and this 120 is the interior angle. And if you work out those two angles for your shape, you're likely to get some marks. Let's do the same thing for the 5-sided shape. I'm going to do 360 divided by 5. So it's how many 5s into 360. 5s into 3 is naught remainder 3. 5s into 36, well, 5 7s are 35, so it'll be 7 remainder 1. And 5s into 10 is 2. So 360 divided by 5 is 72. And I'm just going to follow the same routine I did over here. I'm going to do 180 take away that answer. And 180 take away 72 is 108. And again, I don't know where I'm going with the problem, but I'm working out the exterior angle, which is 72. And I'm working out the interior angle, which is 108. And what we can see now is we solve most of the problem. We know that this angle here is 120. We know that this angle here is 108. We just need this missing angle A. So what I'm going to do is say, okay, that's creating a full circle or angles around a point. So I'm going to start with 360. I'm going to take away 108. And then I'm going to take away 120. Altogether, I'm taking away 228. And I promise you, 360 take away 228 is the 132 that they're talking about in the question. Final question of this paper, guys. We've got a probability tree. Part of it's been filled in for you. We've got a bag containing 4 red counters and 3 blue counters. Someone's picking a counter and replacing it. That's good news. And then picking a second counter. First thing, filling the tree. Well, if this is red and it's already been done, we know altogether there are 7 counters. And in fact, there are always 7 counters in the bag. So every one of these probabilities is out of 7. We know there are 3 blue counters. So wherever it says blue, I'm going to put a 3. Blue here is 3. And we know that there are 4 red counters, so there's just a missing red part there to fill in. Just double check, your branches always add up to 1. 4 7s add 3 7s is 7 7s, that's 1. Same up here, same here, 4 7s add 3 7s, 7 7s, or the whole 1. We're asked to find the probability that Jack picks 2 red counters, so we're travelling along this branch and getting a red counter, then along this branch and getting a red counter, and all we need to do is sweep up those probabilities as we travel. So red is going to be the first 4 7ths, and we're going to multiply by the second 4 7ths, always multiplying along these branches. And multiplying fractions is easy. Multiply your tops, 4 4s is 16, multiply your bottoms, 7 7s is 49. That is the final answer. It doesn't say to simplify, there's no need to go to a decimal, we just got full marks. I hope you found this useful, guys. Remember, it is just a best guess based on what's not been tested yet in paper 1. There's no guarantee any of these questions are coming up, but some of them should do, and a good chunk should do. Your best strategy is to revise as much as possible and get comfortable with as much content as possible. Keep revising. Good luck. You got this.